In this video, we'll be solving polynomial equations using the factoring method. So basically, you're going to do factoring like we did in the previous lesson, but then we're going to use our factors to solve. Always make sure equations are equal to 0 before you start factoring. And then your first step should always be to look for a GCF, or greatest common factor, which means the biggest number that all three numbers can be divided by, or all the numbers can be divided by. Then you're going to check, once you factor that out, if you do, what's in the parentheses is a trinomial or a binomial. If it's a trinomial, you'll use the method with the blanks. If it's a binomial, you're going to look for a difference of squares. Once you have it factors as much as possible, then you'll set each factor equal to 0 and solve. So here, I'm going to start by looking for a GCF. I notice that all of these have an a. So I'm going to take out the one with a lower exponent, which would be a cubed. And I can work backwards. I can divide by a cubed to see what would go in parentheses. Remember, when you divide, you subtract exponents. So a to the 5th divided by a cubed is a squared. A to the 4th divided by a cubed is a to the imaginary 1. And a cubed divided by a cube cancels because 3 minus 3 is 0. Now I'm going to check what's in the parentheses and see if I can factor it further. Here I notice in the parentheses I have a trinomial. So I'm going to factor that trinomial. I can already set up my blanks. A times a are my factors. The cube's going to stay out in front. So I have blank times blank equals 20, because you always use the last number. And blank plus blank equals -9. So I'm going to make a list of numbers that multiply to 20. 4 and 5 will give me 9. Both of them have to be negative, because when you multiply two negatives, you get a positive. So here I can put my -4 and my -5. So now I have it completely factored, because I don't have any exponents in those new factors. They're just a, not a squared or a cubed. So your last step is going to be to solve. And the way you do that is you just set each factor equal to 0. And then solve them individually. So here, we would do the cube root of 0, which is just 0. The opposite of -4 would be to add 4. Here, the opposite of -5 would be to add 5. So my solutions are 0, 4, and 5. On this next problem, I'm going to factor to solve. So remember, you always look for a GCF first. So I notice this one has a 2 and an 8. Both of those can be divided by 2. And they also both have x, the one with the lower exponents, x to the 6. 2 over 2 is 1. They cancel. The 1 can be imaginary. X to the 7th over x to the 6 is x to the imaginary 1. 8 divided by 2 is 4. And x to the 6 over x to the 6 cancels. So I have 2x to the 6 times x plus 4. Now, if I look at this parentheses, it can't be factored more because there's no exponent. X is to the imaginary 1. So I'm ready to solve. So I'm going to set each of my factors equal to 0. Here I would divide by 2. And then I would do the 6th root of 0, but that's just going to be 0. Here I would do -4. So I get -4. So my solutions are 0 and -4. This next one, I'm going to start again by looking for a GCF. So here I can factor out x cubed. X to the fifth divided by x cubed is x squared. And here the x cubes cancel because they're the same. Now I'm going to look at my parentheses here. It has x squared, so chances are it could be factorable. I notice it's a binomial. If it's a binomial, you look for a difference of squares. So here I notice we already have x squared, but 36 is actually 6 squared. So this is considered a difference of squares. So we can write it with two parentheses, both with x and 6. One has to be plus, one has to be minus. I'm just going to bring down that x cubed. So I just factored this a little further. Now that I have all my factors, I'm going to set each of them equal to 0 and solve for x. Here I would do the cube root of 0, but that's just 0. Here the opposite of plus 6 is minus 6. Here the opposite of minus 6 is plus 6. So my solutions are 0, negative 6, and 6. In this next problem, I look for GCF. There's no GCF right now because not both of them have numbers and not both of them have n. So next, I notice it's a binomial. So I'm going to check for difference of squares. So here, I notice that n to the fourth is actually n squared, and 121 is 11 squared. So this is a difference of squares. So when I set up my two parentheses now, I'm going to put n squared and 11 in both of them. And one will be plus and one will be minus. Now from here, you would want to look for another difference of squares. The first one is plus, so it's not. The second one is minus. So it is a difference, but 11 is not the square of a number, so we can't factor this anymore. So we'd stop there, and then our next step would be to set each factor equal to 0 and solve for n. Here the opposite of squaring would be to square root. Remember, anytime you square root, you're going to have that positive or negative symbol. So positive or negative square root of negative 11. And remember, we learned in the previous unit or chapter that you can't square root negatives. So if you do that, it's still going to be square root of 11, but you're going to have an I at the end to show it's imaginary. Here we're also going to square root. So we have positive or negative square root of 11. This one doesn't need an I because it was not a negative root. I'm going to leave those square root of 11 because it's not a perfect square root. So you don't want to change it to a decimal and lose accuracy. So here my solutions are n equals positive square root of 11i, negative square root of 11i, positive square root of 11, and negative square root of 11. So we have 4 solutions. Here in this next problem, I notice there's no GCF because not all terms have a number in front and not all of them have an x. So next, I'd see that it's a trinomial. So if it's a trinomial, I'm going to want to try to do the trinomial method. So usually I set up 2 parentheses. In this one, since it's x to the 4th, we would start each of them with x squared times x squared times x squared will give you the x to the 4th. So now that I set those up, we can do the method with the blanks. So it's similar to the quadratics where it starts with x squared and you do x times x. But if it's x to the 4th, you do x squared times x squared. So here I'm going to do my blank times blank equals negative 48 and blank plus blank equals negative 13. For 13, we would use 3 minus 16. So in my parentheses, I'm going to put a positive 3 and a negative 16. So now I factored the trinomial. And now I'm going to look within each of these parentheses and see if they can be factored further. Now they're binomials. Remember, when they're binomials, you look for difference of squares. The first parentheses I already noticed is addition. So it's not a difference, but the second one is. So that can be rewritten as x squared minus 16 is actually 4 squared. So this one is a difference of squares. So I could rewrite it as x plus 4 and x minus 4. My first parentheses, I'm just going to bring that down. I couldn't factor that one further. So now that I have all my factors completely factored, I'm going to set each of those factors equal to 0 and solve. Here I would do minus 3. The opposite of squaring would be to square root. Remember, when you square root, you can have a positive or negative answer. Now, since this is square root of a negative, that means it's going to be imaginary. So I'm just going to write it as square root of 3 with a little I at the end. Here, the opposite of plus 4 is minus 4. The opposite of minus 4 is plus 4. So my solutions are x equals square root of 3i, negative square root of 3i, negative 4, and positive 4. Now, in our last example, it's similar to the problem we just saw. We have a trinomial. There's no GCF. So since it's a trinomial, I'm going to set up my two factors. We want them to multiply to b to the 4th, so we're going to put b squared in each of them, because b squared times b squared is b to the 4th. And now I can set up my blanks. Now I'm going to make a list of numbers that multiplies to 24. I notice 6 minus 4 will give me 2. So in my parentheses, I can put a positive 6 and a negative 4. And now I'm going to check each of these parentheses and check if they can be factored further. So now you'll see they're binomials. So we're going to check for a difference of squares. This first one's plus, so it's not a difference, but the second one's minus, so it is. So I'm going to check if I can rewrite those as the subtraction of 2 squares. 4 is 2 squared, so this works. So it is a difference of squares. So my factors would be b plus 2 and b minus 2. The original factor from the front, b squared plus 6, I'm just going to bring down. So now we're done factoring. We factored it as much as possible. Our next step is to set each factor equal to 0 and solve. Remember, when you square root, it's positive or negative. If it's a negative root, you can take the negative out and put an I at the end to show your answer is imaginary. So here our solutions are b equals square root of 6i, negative square root of 6i, negative 2, and positive 2. So just to summarize factoring, always look for GCF first, take that out. Once you do that, if you have something in parentheses, check if it's a trinomial or a binomial so you can see which method you would use from there. If your original equation is already a trinomial or binomial and there's no GCF, then right away you can check if you're going to use the trinomial method or check for difference of squares method.